Hey everyone, it's Justin again. At this point, we've learned how to use all three methods for solving systems, but we've also learned that sometimes systems don't have a solution, or they might have infinite solutions. In this video, we're going to be discussing how to identify these types of systems without having to graph them. First, let's review what these look like when graphing. A system with no solutions will have parallel lines that never cross. A system with infinite solutions is made of the same exact line overlapping with itself. But what if we don't want to graph, or the equations are too big and difficult to bother with graphing? We briefly discussed before how this turns up when using the substitution method, but let's review it and do some practice. If you attempt the substitution method and end up with a false mathematical statement, like 21 equals 5 here, which can't possibly be true, then there's no solution. That result is telling you it is as impossible to solve this system as it is for 21 to equal 5. On the other hand, if we use substitution and get a statement which is always true, such as 4 equals 4, that means that there are infinitely many solutions. Take this always true result to mean these lines are the same, just like 4 and 4. Let's do one example with substitution. Say we've got the equations y equals negative 4x minus 1 and 8x plus 2y equals negative 2. Since the first equation already has y isolated, we decide the best method here would be the substitution method. So we take the second equation, plug it into y using the first equation, and solve. We distribute the 2 across the parentheses, then the 8x and negative 8x zero out, and we're left with negative 2 equals negative 2. So which one of our special cases is this? If the result is the same on both sides, then the original equations create the same line. This is a case of infinite solutions because the lines are actually the same. The good thing is, with elimination, it's just as easy, if not easier. Take this system, for instance. In order to use elimination, we need opposite terms. So let's multiply the top equation by negative 1. Now we've got negative 2x and 2x. So elimination will work. Now we just combine the equations. 2x and negative 2x zero out and eliminate. And so will y and negative y. So we get 0 equals 2. Hopefully at this point you've already figured out what the answer here is going to be. There is no solution to this system. The indicators for no solution and infinite solutions are the same for the elimination method as with the substitution method. In this case, the false statement, 0 equals 2, is telling us the system can't be solved. What happens if the system has infinite solutions? Well, first we make sure everything is in the same order, multiply to prepare for elimination, and then combine the equations. Negative 2y and positive 2y, zero out. Positive 10x and negative 10x, zero out. And negative 20 and positive 20, zero out. So our results came out to 0 equals 0, which means what? The equations in our system were actually the same line, giving us infinite solutions. So remember when I said recognizing systems with no solution or infinite solutions can be super easy with elimination? Here's why. You may have noticed this in the example we did, but the example with no solution had two equations that were almost the same. Their x term and y term were identical, but their constant was different. This is the telltale sign of a system with no solution, having equations that are almost identical, but the constants are different. Here's another example. Notice how the x and y terms are the same, but the constant is different. We know it'll have no solution without having to work it out. In this example, the x and y terms have opposite signs, but if we multiply the top equation by negative 1, now the x and y terms are exactly the same, but the constants are different. No solution. Infinite solutions are the easiest to recognize because the moment you realize you have the exact same equation, you're done. For instance, here's the example from a moment ago. In the process of setting it up for elimination, we multiplied the bottom equation by 2 and got this result, where the two equations are exact opposites. If we multiply either equation by -1, changing all the signs, we end up with both equations being exactly the same. This means the lines are the same, so there will be infinite solutions. For this system, if we multiplied the top equation by 2, it would perfectly match the bottom equation. So there are infinite solutions here as well. See if you can prove that this one has infinite solutions. I'll give you a hint. Make sure that the like terms are lined up. To recap, both substitution and elimination do the same thing when a system has either no solutions or infinite solutions. If there are no solutions, you'll get an impossible statement, like 2 equals 9. And if there are infinite solutions, you'll get an always true statement, like -3 equals -3. In the final lesson of this unit, we're going to be looking at scenario problems involving systems. Just like problems out in the real world, some will have a definite answer, some will have many possible answers, and some just won't have a correct answer at all. Luckily, you've now got all the tools to be able to tell the difference. See you next time.